We're now going to add vectors which are in component form. In order to do this, we just add all of the I components together and we add all of the j components together. So in our example, we're given vector p in component form, vector q in component form, and vector r in component form. And we want to work out vector p plus vector q plus vector r. So when we get our answer, it's also going to be a vector. So I am going to give the vector that we're trying to find a title, and the vector we're trying to find is p plus q plus r. What we do now is replace vector p with its I and j components. So vector p is 4i plus 2j. I'm going to put brackets around the I and j components because they both belong to vector p. So we're keeping those together. Then we copy down our plus and repeat for vector q. So replace it with minus 5i plus 3j and put it in brackets. Then we copy down our plus, and again we put vector r in brackets, so its I and j components are minus 3i minus 3j, close brackets. So what we're going to do now is add all of the I components together. So we've got 4i plus minus 5i, so that becomes a minus. So 4i minus 5i is minus 1i. So at the minute we've got minus 1i or minus I, and then we're adding on minus 3i. Again, a plus and a minus here give you a minus. So we have minus 1i minus 3i. That's going to leave us with minus 4i. We're now going to add all the j components together. So we've got plus 2j plus 3j. That's going to give us 5j. 5j plus minus 3j is going to give us 5j minus 3j, which is going to give us plus 2j. So we've now found the I and j components of our vector, which is our answer. Again, put brackets around it because both of those components belong to our answer vector. And that's our answer. We're now going to look at the meaning of adding vectors. When we add vectors together, this means we are joining each vector nose to tail to find the resultant vector. So, if we take the same three vectors again as before, p, q and r, what we're going to do is add them physically speaking. So, first thing I'm going to do is pick any point at all on the grid here with I and j axes, and I'm going to let that point be the tail of vector p. So for example, I'm just going to pick a random point here, and that point is going to be the tail of vector p. Now, I want to plot the nose of vector p. So to get from the tail to the nose, we have to move 4 units to the right. That's what the I component tells us. And then we have to move 2 units up. That's what the j component tells us. So we're at the tail of vector p. To get to its nose, we move 4 units right. 1, 2, 3, 4. And then we move 2 units up. 1, 2. And that is going to be the nose. I'm going to join those 2 points together to draw vector p. And then we're going to put an arrow on it. The arrow, remember, always points at the nose. And I'm going to label it. That is vector p. Now, what we're now going to do is where the nose of vector p is, we're going to join that to the tail of vector q. So vector q is starting here. So to get from the tail of vector q to its nose, we have to move 5 units to the left because the I component's negative, and then we have to move 3 units up because the j component's positive. So we're now at the tail of vector q. Remember, the tail of vector q is joined to the nose of vector p. So we're now moving 5 left, 1, 2, 3, 4, 5, and then we're moving 3 up, 1, 2, 3, and we'll be at this position here. So that is going to be the nose of vector q. So I'm going to join the tail of vector q to its nose. And again, the arrow always points at the nose, and I'm going to label that vector q. So where the nose of vector q is, that's going to become the tail of vector r. So how do we get from the tail of vector r to its nose? Well, the I component tells us we're going to have to move 3 units left because it's negative. And the j component is telling us we then have to move 3 units down because it's negative. So we're now at the tail of vector r. So to get to the nose, we have to move 1, 2, 3 units left. And then we have to move 3 units down. 1, 2, 3. And that will be the position of the nose of vector r. So let's join the tail to the nose of vector r. And again, the arrow points at the nose, and we're going to label that vector r. So when you're adding vectors together, you're joining them nose to tail. Once you've done that, you can then find the resultant vector. Now, the resultant vector is the vector that joins the tail of the first vector to the nose of the last vector. So I'm going to join tail of the first vector to the nose of the last one, and the arrow is going to point to the nose of the last one, and I am going to call this vector here capital R. So R stands for the resultant vector. So when you add any number of vectors together, you're joining them nose to tail, and in doing so, you're finding the resultant vector. Now, the resultant vector here, we can actually work out what it is, because this is going to be its tail. So to get from the tail to its nose, we'll have to move 1, 2, 3, 4 units left. So the I component is going to be minus 4i. And then we have to move 2 units up, 1, 2. So the j component is going to be plus 2. So vector r, the resultant, is going to be minus 4i plus 2j. And what you'll notice is that it's exactly the same as the answer we got when we did it without a diagram. So if I just take you back, that's what we got when we added P, Q and R, just algebraically, minus 4i plus 2j. And then when we actually joined the vectors nose to tail, which is equivalent to adding them, we got the resultant vector, which is minus 4i plus 2j. So that's what we mean when we add vectors. We join them nose to tail to get the resultant vector. And the resultant vector joins the tail of the first vector to the nose of the last vector.